Okay, we're going to look at one last type of transformation in this series of videos, and that's horizontal reflections. So once again, we're starting from the same parent function, the same graph, and the same table of values. And now, given y is equal to f of x, we're asked to graph y is equal to f of negative x. So just as before, we're being asked to change the input before it's put into the function. Here we are replacing x with negative x. So in our table of values down here, if we want to make a table of values of x versus f of negative x, when x is negative 4, f of negative x, again we plug the negative 4 in there, is going to be f of negative 4, which is equal to f of positive 4, which from the table above here, f of 4, when x is 4, f of x is 0. So f of 4 is 0. When x is equal to negative 2, f of negative 2 is going to be equal to f of 2, which is 2 from the table above. F of negative x becomes f of negative 2 is equal to f of 2, and looking it up, we get an output value of 2. When x is 0, f of negative 0 is still f of 0, so looking it up on the table above, we get 0. When x is 2, f of negative x is f of negative 2, and from above that's equal to negative 4. When x is 4, f of negative x is f of negative 4. And looking above, that's equal to 0. So let's plot these points. We've got the point negative 4, 0, the point negative 2, positive 2, the point 0, 0, the point 2, negative 4, and the point 4, 0. So if I connect these, you can see that what's happened is the graph has been reflected horizontally or flipped horizontally in the y-axis. It's as if the y-axis was a mirror and it had been flipped left to right across it. So replacing x with negative x gave us a horizontal reflection in the y-axis. So when we were looking at horizontal stretches before, we introduced this coefficient k inside the brackets in front of the x. And it's the same thing again here. When this, before we said, say this k was 3, for example, y is equal to f of 3x, that would mean the original f of x function was being horizontally stretched by a factor of 1 over 3. Now we're adding the fact that we can consider what the sign of k is. So if k is negative, then that's going to give us a horizontal reflection in the y-axis. As another example, if you started from the parent function y is equal to root x, the square root function, if we replace that x with negative x underneath the square root sign, then what we're doing is we are flipping the graph horizontally, or horizontally reflecting it in the y-axis. So important to note that while vertical transformations are somewhat intuitive, they kind of do what you initially expect them to. When you add 3 at the end of the function, you move it up 3. When you multiply the whole function by 2, it gets vertically stretched by 2. The horizontal transformations are somewhat counterintuitive. When you're changing things inside the brackets of the function notation, they seem to do the opposite of what you think at first. When you add it, when you replace x with x plus 2, you move to the left by 2. When you multiply x by 2, you're actually horizontally stretching by a factor of 1/2. So there's a little bit of counterintuitiveness to it at first, so just keep that in mind. So we've now covered vertical and horizontal translations, stretches, and reflections.